Three numbers whose product is the biggest possible from the array. Here's the narration. Here you're given a list of whole numbers and your job is to pick three of them that multiply together to give the largest possible result. Once you found that trio, return their product. Intermediate level, you'd think the three largest numbers always win, right? But two big negatives multiply into a huge positive, and suddenly the smallest numbers beat the biggest. By the end, you'll spot this trap in seconds. Here's why this problem fools smart people. The word largest feels like the whole answer. But size isn't the same as product once negatives enter, and your brain skips right past that. Watch how one input turns the obvious rule inside out. We are given a list of numbers, and we pick exactly three of them. We want the three whose product is the largest possible. So for 1, 2, 3, 4, the best pick is 2, 3, 4 giving 24. The gut instinct is simple. Sort the numbers. Take the three biggest. Multiply them. And honestly, this works fine for list of all positive numbers. It feels done. Now try -9, -8, 1, 2, 3. The top three give 6. But -9 times -8 is 72 times 3 is 216. Here's the trick. Two negatives cancel into a big positive. We only need two ideas. Sorting just lines. Everything up smallest to largest. Like arranging cards in your hand. And Python's max just hands back the bigger of two numbers. That's the whole toolbox. So here's the pattern I call two corners. After sorting, the answer is always at the extremes. Either the three largest on the right or the two smallest on the left paired with the single largest. In short, you only ever check two candidates. First, we sort the list in place. Why sort? Because it forces the biggest values to the right end and the smallest, including negatives, to the left end. Now both candidates live at predictable spots. Candidate A is the last three, the biggest values. Candidate B is the first two, a possible negative pair, times the single largest. We return whichever is bigger, and that's the answer. Clean. Quick challenge. Pause the video. For -5, -4, 1, 2, 3, what does our function return? Think about both corners before I show you. Top 3 gives 6, but -5 times -4 is 20, times 3 is 60. 60 wins. There's the pattern doing exactly what we built it for. You can avoid sorting entirely. Walk through once, tracking only the two smallest and three largest numbers as you go. Plus side, it's faster. Downside, more variables to juggle, and honestly it's easy to get one wrong. Sorting is n log n time and constant space, but it's 5 lines you can't mess up. The scan is linear time, technically faster. My honest take for an easy with tiny inputs, just sort. The speed gain is overrated here. All negatives like -1, -2, -3, the three largest, meaning closest to 0, give -6 and our max still picks correctly. I once shipped this only checking the top 3 and it failed on all negative input. Embarrassing. The two-corner check survives it for free. Remember the case that broke us? Biggest 3 losing to two negatives? Now you see why. The answer always hides at the corners, so you check both and take the max. New daily drops tomorrow, same time, where this same corner trick cracks a much harder summary problem. You made it to the end. That's the hard part. Liking and subscribing is easy.